f of a plus f prime of a x minus a. And we were given 4. So that was our 4. And the function, let me see, what was the function? Where is my function? So a couple of you came up with a function that was not linear. If it says linearization, I have to find a linear function, right? And the function was f of x equals 2x cubed plus x. So then f prime of x will be 6x squared plus 1. And I plug in 4 to get this number, I plug in 4 to get this number, and then x minus 4. So I calculated that f of 4 was 132, and f prime of 4, you just plug them in, was 97. So then the linearization is 132 plus 97, x minus 4, and when you distribute and combine like terms, you get 97x minus 256. Anything, other questions, anyone? Anything else? Okay, in that case, we'll start. You can always stop me if you remember something, right? You know that. Chapter 4. Chapter 4 is a big chapter, very important chapter. So I'm just going to start slowly, and meaning I don't even want to mention the title just yet. Well, the title is integrals. But what does that mean? I mean, well, we're going to get there. So first, number 1 on the list is something called antiderivative. An antiderivative, and I will explain in a moment what it means, can be really of 2 types. One called most general antiderivative, and the other one, just one, unique function. This one is the most general antiderivative, and this one just is one function, the antiderivative, one specific one. So first of all, what is this? So let's analyze and understand what this means. Let's suppose I'm given a function, this one. I'm copying it. And I'm asked to find its derivative. We've been doing this for a few months now, so we have it's 6x squared plus 1. And for some reason, and I'll explain also why, let's say we are given the derivative. Given f prime of x, which is 6x squared plus 1, find f of x. Okay? This f of x is the antiderivative of this function. I don't have it. Yes, I do. It's covered right here. So I'm given like the velocity function, and I'm asked to find the distance function going backwards. So here we had the function, let's say this is the distance function. I'm differentiating to get a function for the velocity. Okay, now I'm given the velocity, and I'm asked, can you go back and find the distance function? For example, another example. I am given the rate of change of profit. And I'm asked, can you find the profit? You're given the rate of change. Can you find the profit going backwards? I'm given the marginal cost, which is the derivative of the cost. Can I find the function that is the cost function, whose derivative is this? So that's the antiderivative. So we are going backwards to find the function. This is the antiderivative of this function. So let's see how we determine it. And there are certain rules. So here's one rule. If I have, for example, x to the third, I'll come back to the function. I just need to explain some rules. Which function prime will give us x to the third? Well, the answer is a fraction. I have to increase the power by 1 and divide by that number. How come? Okay, let's differentiate this. 4 comes in front. I simplify it with 4 in the denominator, and I have x to the third left. So the general formula, and of course, I can have anything like this, plus any constant for this situation. 4 comes in front, I simplify, and I have x to the third, and c prime, a constant prime, is 0. So from here we can deduce, so to speak, the general form, the general rule. X to the nth power, or I should say n plus 1, divided by n plus 1 plus a constant c. What does this represent? Is our xn. How come? I bring down n plus 1, I simplify with n plus 1, I subtract 1 from the power, and c prime is 0. Let's come up with another rule. Let's say I want to determine or find a function, of course plus c, plus a constant c, whose derivative is 1 over x. Can anyone give us an idea of what could this be? In other words, I'm asking which function I differentiate to get 1 over x. And there is only one function that we differentiate to get 1 over x.
Natural log of x?
Excellent. Brilliant. Thank you very much. Of course, we cannot forget that absolute value. So natural log of absolute value of x plus a constant c prime will be 1 over x. Awesome. Thank you. Great. What about which function do I differentiate? Of course, plus a constant c, because when I differentiate the constant, I get 0. Which function I differentiate to get e to the x? And there is only one function.
E to the x.
Of course, e to the x. Very good. Thank you very much. E to the x prime is e to the x. Constant prime is 0. Great job. Okay, so we have some information now. Let's come back here. We still don't know. We have no idea what that is. So we are given f prime of x, which is 6x squared plus 1. And we want to construct the function. Could be the unique antiderivative, but this time we're going to determine the most general one. Okay, so I have f of x. 6 can stay, of course. What function prime will give us x squared? And remember, it has to be a fraction. We have it right here. So if I want the answer to be x squared, which function do I differentiate? Of course, I have to consider the constant as well. But which function will I differentiate to get x squared?
X to the third divided by 3.
That's it. Very good. Very good. Thank you so much. Plus, which function I differentiate to get 1? So,
X.
yes, x plus a constant c prime is indeed 1. Good. So this is plus x. Plus, which function prime will give us 0. 0 is always there. We don't see it, but we know it's there. So which function prime will be 0? Right here. Plus a constant c. This is the most general antiderivative of this, of f of x equals 6x squared plus 1. What does this mean? Infinitely many functions. Yes, I will simplify this and I get the what did I do? Yeah, 2x squared plus. So I wrote this incorrectly here. Of 2x of yeah. That's it. Yes, of course. 2x squared plus x plus c is the most general antiderivative of this function. So let me write it again so it's clear. You just see the same thing. So 2x cubed plus x plus a constant c. So these are infinitely many functions. How come? If c is 1, I get a function. If c is 0, I get another function. If c is negative 500, I get another function. So now this one was one specific, a unique, just 2x cubed plus x, whose derivative is this. But all these functions have the same derivative. Let's try. 6x squared plus 1 plus 0. 6x squared plus 1 plus 0. All of them have the same derivative. So what is the difference between these two? This is a family of functions, the most general antiderivative, infinitely many, because c can be anything. And the unique function is just this, in which specifically c is 0. Okay, we have a notation. In my STEM class in the Math 191, I don't present the sequence that this book presents, but I'll stick with the book. So, notation for the most general antiderivative. And I'll explain, hopefully today, why we use this notation. See, this is a regular S standing, let's say, for sum, right? We're going to take this letter and stretch it. We're going to stretch it as much as we can. This stretched S with f of x times dx, okay, not f prime, right, but f of x dx. This is called indefinite integral. The indefinite integral. So it stands for sum. I'll come back and explain why, and I'll come back and explain tell you why we use this and why we use f of x times dx. That's why I think that this is not the right moment, but that's how the book presents it, and I'll go along with it. Okay, so we are summing something. Soon I'll explain what we are summing. So it's a long stretched, elongated s, f of x times dx, and this is the indefinite integral. That's the name of it. Also equals to the most general antiderivative. So when we talk about this function, this will give us that answer. Let's put it in and explain again step by step how we get this. So we were looking at the integral, the indefinite integral from 6x squared plus 1 dx. This was our function from the beginning. Okay. So every time I touch anything,
This other computer, it just acts up. I'm not sure why it does that. Okay. So here was our starting point. And we wanted to determine the steps will be identical, but I just want you to see the same steps in the integral. That's all I'm doing right now. So this was the function, which is right here, which is this function, dx. And we want to find the answer, which is the most general antiderivative. Okay, so then we know what this is. 6, you already told me, x to the third over 3. Why? Because this prime is x squared plus this function is prime is 1 plus a constant c. Exactly what we just had, which is 2x cubed plus x plus c. Another minor rule I would like to look at, and then we'll choose problems from the book. Any problems you want. We can write this also as the integral, the indefinite integral from e to the x dx. Can anyone give us the answer for this? We already wrote it a few minutes ago in a different way.
Is it just EX?
E to the x. Remember, EX means product. We have to say e to the x plus a constant c. Awesome. Excellent. That's it. So this is the indefinite integral from e to the x dx, which is this. Now, what if I have the integral from e to 4x dx? There must be an adjustment here. What will be the adjustment? So remember, when we differentiate e to dx, we get e to dx. But when I differentiate e to 4x, I get e to 4x times 4. So the answer has to be divided now by 4. Very easy to always check. Always check. If I differentiate this, I have to get this. If I differentiate this function, the most general antiderivative, I have to get e to 4x. If I differentiate this and I do not get e to 4x, this is incorrect. So if I differentiate this, I get e to 4x times 4 over 4. I simplify the 4 and I get back e to 4x. Now, one quick example here. The integral from e to 10x dx. What will the answer be? What will be the most general antiderivative, in other words, of e to 10x? Can anyone give us the answer? It's okay if you're wrong. Always.
E to 10x over 10
Very good.
plus C.
Exactly. Awesome. That's it.